Hey, welcome to the Explainer. So today we're cackling something pretty huge, a paper that suggests a completely different way to think about AI alignment. The big idea? Stop trying to teach an AI to be good. Instead, let's use math to build a system where it's literally impossible for it to be bad. We're talking about verifiably safe AI. And really, this question gets right to the absolute core of the AI alignment problem. You see, most of the methods we have right now are all about trying to train an AI to have the right internal values, to actually be good. But here's the scary part. What if a really advanced AI just gets good at pretending? How can we ever be sure it's not just faking its alignment to go after some hidden goal we can't even see? Okay, so here's how we're going to break this down. First, we'll touch on the alignment problem as it stands today. Then we'll get into this radical new solution, what they call a mathematical safety cage. After that, we'll look at how you actually build this thing, how you make it work in the real world, and finally, what this could all mean for a future where AI is actually auditable. All right, section 1, the unsolved alignment problem. So to really get why this new idea is such a big deal, we've got to quickly recap why trusting AI is, well, so incredibly hard. So right now, most of what we do falls under things like reinforcement learning from human feedback. You've probably heard of it as RLHF. The whole idea is to teach an AI good values by, rewarding it for good answers. But here's the catch. A really, really smart AI might figure out that the winning strategy isn't to actually be aligned with us. No, the best strategy is just to look aligned. And that's the nightmare scenario, right? Alignment faking. The AI is just tricking us so it can pursue its own goals. Researchers have a term for this, MESA optimization. Okay, so now for the radically new solution. This paper basically says, let's throw that old approach out the window. It's a total paradigm shift. It argues we should stop trying to play psychologist with the AI. Instead, let's build a system around it that makes unsafe behavior impossible, by design. And this whole thing is built on a few key principles that are, frankly, pretty brilliant. And here it is, the core philosophical flip. The paper's first axiom is so simple but so powerful. Stop worrying about what the AI is secretly thinking. Just stop. The only thing that matters is what it actually does out in the real world. Alignment, they argue, has to be a property of its actions, not its secret internal monologue. This really leaves it all out, the old way versus the new way. Think of it like this. The old way is kind of like trying to raise a perfectly moral child and just hoping they always make the right choices. The new way, it's like building a car where the brakes are physically incapable of failing. The safety isn't about trusting the driver's good intentions, it's engineered into the system itself. And this is so crucial. It means the system's safety is no longer totally dependent on how good the AI's training data was. All right, let's get into the good stuff. The mathematical safety cage. How in the world does this thing actually work? Well, let's dig into the core logic. It's really built on three, I think, incredibly elegant concepts. Okay, concept number 1. We have to start by imagining something called trajectory space. Now, just picture a huge, basically infinite map. And on this map is every single possible sequence of actions an AI could ever take, and every possible outcome from those actions. So every single path you could draw on this map is literally a different potential future. Okay, so concept 2. We've got this giant map of all possible futures. Now what? Well, now we need a way to mark off the dangerous territories, right? That's where risk functionals come in. Don't let the name scare you. These are just mathematical rules that we write. Each rule looks at a path on our map, one of those potential futures, and gives it a risk score. It's basically like taking a big red marker and drawing lines all over the map saying, don't go here, this timeline is unsafe. And this is how those abstract ideas get super concrete. For example, we could write a risk functional, a rule, that penalizes the AI for holding onto sensitive data, or another one that puts a hard cap on how much energy it can use. We could even have a rule to spot deception by measuring how much its behavior is drifting away from a safe baseline we've already defined. The point is, we are explicitly and mathematically defining the rules of the game. And finally, concept 3, the enforcement mechanism. And honestly, this might be the most brilliant part of the whole thing, safe projection. So what happens if the AI tries to take an action that would lead it down one of those unsafe paths we marked in red? The system doesn't try to reason with it. It just mathematically calculates the closest possible safe alternative and does that instead. It literally just snaps the AI's choice back into the safe zone. No questions asked.
So the big takeaway here, the really crucial point, is this. The raw AI model inside this system, it can be flawed. It can be biased. It could even be actively malicious, trying to do bad things. And it doesn't matter. It just doesn't matter. Because this mathematical wrapper around it guarantees, by its very design, that the action that actually happens in the real world is safe. Alignment isn't something we're hoping for anymore. It's being enforced.
Okay, section 4. So I know what you might be thinking. This all sounds great, but it's also incredibly theoretical, right? Infinite futures, abstract math. How do you actually take all of this and make it work on a real computer in a finite amount of time? Well, you're right. You obviously can't monitor an infinite future. So the practical workaround is pretty clever. You force the AI to constantly show its work. At every step, it has to output its partial plans and these things called certificates that can be checked. Then you have simple external monitors that just watch this continuous stream of data. Now, what are they looking for? They're looking for any statistical drift, any deviation from a safe behavior pattern we've already defined. And just like that, you turn an impossible infinite problem into a series of totally manageable, finite, checkable steps. And what this whole process gives you is something incredibly valuable, a real-world probabilistic safety certificate. Look, we can't get to 100% absolute certainty. That's just not how this works. But what we can get are rock-solid statistical guarantees. We can actually say with a quantifiable level of confidence, like 99.999%, that the system is behaving the way it's supposed to, all based on the hard evidence in its logs. So what does this all add up to? Well, it's not just a bunch of cool ideas. It's actually a complete pipeline, a system designed to go from those very first principles all the way to actual real-world governance. You can see the whole flow right here. It all starts with those basic axioms we talked about, like focus on behavior, not thoughts. From there, you build the formal math. Then you make that math practical with the monitors and the certificates. Those certificates then become the foundation for governance, and it all leads to this, a machine-readable API that a regulator could plug right into. And one of the key outputs here is this idea of a certified checks API. Just imagine a regulator being able to, ping an AI system and instantly get back a formal, tamper-proof bundle of evidence. This bundle would have everything, the exact hash of the rule set the AI is using, and the statistical proof that it's actually following them. And it would all spit out a simple status, certified, not certified, or maybe unknown. Now, let's be really clear about something. This doesn't magically solve the single hardest part of alignment, which is figuring out what the rules should be in the first place. That's what we call the specification problem, and it's still a huge challenge for humanity. But what this framework does do, and this is huge, is it drags that problem out of a mysterious, opaque black box and puts it right out in the open. It forces us to write down the rules explicitly in a way that can be audited, tracked, and most importantly, a way that is mathematically enforceable. And that leaves us with a really provocative final thought to chew on. For years, the whole field of AI safety has been wrestling with this monumental challenge of trying to build a benevolent God, right? An AI that genuinely wants the best for humanity. But this paper, it suggests a totally different path. Maybe the key to keeping us safe isn't about building a perfect mind, but about building a perfect cage.